All right, so today we're going to talk about operant conditioning. It's also known as instrumental conditioning. And as with the other lectures, will be three parts. We'll talk about behavioral processes, brain substrates, then clinical perspectives. So we saw Edward Thorndike. We were introduced. You tell me. You should be able to hear it through there. We were introduced to Edward Thorndike in the introductory lecture, a bit about his history. And you remember the video about the escaping from the cats from the trial. So today we're going to go back to that general paradigm and go through a lot more detail. So if you remember, Thorndike sort of this early study, and what he was interested in was how behaviors that affect the environment and how we learn from the consequences of our behaviors. And he had these cat boxes, which the cats would be sort of left in. I won't replay the video. You all saw it. And he looked at how long it took the cats to escape from a particular box. What Thorndike set up as sort of the framework for thinking about this kind of learning is that there's a context or a stimulus called the S, a response, the R, which produces an outcome, O, and that this would provide a chain that would sort of guide behaviors such that behaviors with positive outcomes will increase, behaviors with negative outcomes will decrease. And so here the context is a particular box, the response is the sequence of movements that gets it out of the box, and the outcome is both freedom as well as food. So let's look at this. So the SRO, stimulus, response, outcome, is going to be the chain that we're going to come back to over and over again when we study. So there are a number of different paradigms here. Now I should start by saying, so positive reinforcement, the number of different ways in which you can affect someone's behavior. And the terminology is confusing. In fact, we argued with we debated about whether we should just introduce new terminology and just say, well, if we write the textbook, we can come up with the terminology. But eventually we decided to keep the older terminology so as not to alienate the older instructors. But so the words here, so there is positive reinforcement, positive punishment, negative reinforcement, and negative punishment. And the reason these terms are confusing is because we associate positive with good and negative with bad. And so people often think that sort of negative reinforcement is punishment, okay? But it's not. The words positive and negative here refer to adding something to somebody's life, environment, and negative is subtracting. So if I was to redo the terminology here, I would replace positive with additive and replace negative with subtractive. So those would be my terminology, which I think is easier to think about. So positive reinforcement really is this additive reinforcement. If something leads to a positive effects, you're going to do more. Okay, you're adding something. So if you study and that leads to a positive reinforcement, you will therefore study more, okay, because something good happened. Positive punishment, okay, which of course seems sort of, if you think of positive as valent, that can be confusing, but think of this as sort of subtractive punishment, okay? I'm sorry, of additive punishment. If something leads to negative effects, you do it less, okay? So now imagine that I take attendance and it counts, or I give you a quiz in the first few minutes, as I threatened to do, and I may well do again. Then if you arrive late, you get points off, okay? So you have your grade, and you arrive late. Something which is good, which is your grade, your points, gets lowered, okay? So if you lower something good when you do something like that, you'll do it less often. Negative reinforcement, okay, so this really means sort of subtractive reinforcement, means if you do something, if you end something, it avoids a negative effect, okay? So if you take aspirin, okay, then something bad will be relieved, okay? You're escaping from something aversive. So it's negative reinforcement. So the fact that a headache ends, so the idea is that reinforcement tends to promote behaviors, okay? So the headache ends, promotes whatever you did that led to it, okay? But what's happened here, but the outcome that's good, isn't that you've added something good, but that you've taken away something bad, okay? So is it clear? We'll go through this a couple of times. It's a confusing concept made slightly more confusing by the terminology. Negative punishment. Punishment always means something that reduces the likelihood that something's sort of bad for you. but negative means you admit it. So if it ends or avoids a positive effect, you do it less. So an example is during a soccer game, if you curse at the ref, you'll get ejected from the game. Okay? So you curse at the ref less often. You've been punished, okay? But you've been punished by taking something that's good, being in the game, and removing it. So the idea is to be thinking about the reinforcement is increasing behaviors. The reinforcement is something that's good that happened. Punishment is something that's bad. Those are our standard use of the terminology. But positive and negative refer to the ways in which they're either adding good things or subtracting bad things or subtracting good things as a result. So the idea is that there can be sort of good or bad things in your life, okay? And you can either have punishment or reinforcement, and those will affect whether or not you will have more good things or less good things, more bad things or less bad things. So there's sort of like a minus times a minus. You know, it's good to have less of a bad thing. It's good to have more of a good thing. It's good to have less of a bad thing. It's bad, okay, to have less of a good thing. It's bad to have more of a bad thing. So you just have to be thinking about whether what's going on in your life, you know, the behavior that's following an outcome is something good or bad, and whether or not you're getting punished or reinforced. Okay, we'll go through these a couple of times. So let's talk about the actual response. Okay, so initially it was thought to be sort of a rote motor program. In other words, that the animals are learning an exact behavior. But in many cases, it's not just a simple response. So for example, if rats are trained to wade through a maze, okay, that's partially filled with water, and later the maze is flooded, making it impossible to wade, they may be able to get around it another way. So very often the response is some sort of goal-directed program, okay? Some sort of broad behavioral sort of change that it's addressing. And we'll come back to this a little bit. This is maybe not so crystal clear here. What's critical here is that operant conditioning is about contingencies, okay? If, then is a contingency. If you do the response within a particular context, that namely in response to a particular stimulus, you'll get a particular outcome. Contingencies change, and a lot of what's going on in studying learning is studying what happens when contingencies change in the environment. Okay? So for example, if I cry, mom picks me up. Okay? There's mom, I cry, the response is mom picks me up. This is why babies often cry, because they're unhappy, they want to be picked up. So who's the animal being conditioned in this paradigm here? Mom, right? Mom's being conditioned here. Okay? And so, however, imagine mom only does this if she's sober. Okay? That's the context. If mom gets drunk and I cry, then she doesn't pick me up. Okay? So now what I have is a stimulus, response, and outcome. So that this contingency, crying produces picking up, only works in a certain context, namely with a sober mom. The state of mom, stimulus, is called a discriminative stimulus. It tells us which contingency or if a contingency is operative. So if stimulus, response, that's the outcome. If not, do nothing. So an operant conditioning is really a three-part association. There's the context or the discriminative stimulus called the S, the behavioral response, and the outcome. And the discriminative stimuli are crucial for this type of learning because they ensure that we select behaviors that are appropriate to a particular situation. So for example, you would only want to put money into a soda pop machine that's working. You'd only want rats to train to press a lever if they learn that it's going to, if they learn there's a situation where it's going to lead to food. So how do we study these kinds of contingencies, these contextually sensitive contingencies in the lab? Okay, you saw Thorndike's puzzle box. We saw the video and discussion of that in the very first lecture. That was a long time ago. There are a number of reasons why this isn't sort of an ideal situation for the laboratory. You have to, first of all, it's very complex. You have to reset the thing all over again. You have to put the cat back in and lock it all up again. There are a lot of questions about how you're actually measuring learning, what decreases. So it was a good beginning to sort of explore some of the basics, but it's not the ideal setup. The standard paradigm in psychology and then in neuroscience is what's often called a Skinner box. And this is the Skinner box that's used for training. The Skinner box is designed to be a completely self-contained universe. There's a rat. He has a lever. There's often a light, which is perhaps a different colored light, which sets a context. And when the rat presses the lever in response to a particular light, it can then get food, which is the reinforcement. So the outcomes is either food delivery, or there could be shock as an alternative. The behavior is a rate of lever pressing, and the context is a light that signals the box is on, the contingency is active. So note that this animal is free, okay, in the chamber. There's no experimental intervention. This is why it's often called a free operant procedure. Once you put the animal in the box, then you don't need to set it up. It can sort of roam around. It can do whatever it wants. Okay? But many different contingencies can be set up, including these 4 here. So positive reinforcement is if you press the lever, you get food. Okay? So its food is good, okay, and you are increasing a behavior that you were doing. Negative reinforcement, you press the lever to end shock. Okay? So here what you're doing, again, this is what I think about. So it's reinforcing, so ending shock is good. Okay? We all agree ending shock is good, but it's a negative reinforcement because we've taken something away from the environment to be good. Okay? You've got something aversive, which is shock that's going on, and you're subtracting it. That's why I've said a better way to think of negative reinforcement, to recall it, would be to call it subtractive reinforcement. Okay? You're subtracting something aversive, and that's what's reinforcing you. Punishment here, this is you press the lever and you get shock. That should actually be positive punishment, okay, because you've added something, but you've shocked them. And here, negative or subtractive punishment is you're going to take away something good. So you press a lever and the food stops. Okay, so if pressing lever is something you want to eliminate, then you can sort of punish the animal by whenever it presses the lever, you take away food. Okay. So let's examine one of these in particular, the positive reinforcement. Okay, so here's the rat. It's in a box. See if this works. It initially tries many things. Okay, that's the idea that you start with a sort of a broad repertoire of behaviors. This is where the analogy to evolution comes in. We have many different finches with many different beaks. They sort of start out randomly, but after a while, a certain sort of random subset of a broad distribution of behaviors has a certain consequence. Eventually it comes over and it presses the lever somewhat by accident, and it gets a food pellet. Okay. So now it starts hanging around the lever, okay, and starts pressing it, and it happens more and more often. So the idea is that you're starting with an initial random or natural set of behaviors, and whenever the ones that happen are the ones that you want to be repeated, the animal's being reinforced with food. And so eventually, the rat has learned a contingency. If the light is on, and by the way, if the light is on, pressing the lever leads to food, and then it will spend much of its day pressing and eating. Okay? So that's a rat that's been well trained. Okay? And well fed. So this is what the data will look like from an experiment like this. So the pre-training, there's a low spontaneous rate. Without any reinforcement, the rat may occasionally bump up. It may occasionally hit the lever just out of curiosity, but it's very low. If the contingency is introduced, then the responses go up much higher. This is sort of the responses in the presence of the stimulus. The animal discovers the contingency. The rate increases. In extinction, the food no longer is delivered. There's no longer this positive reinforcement, and eventually the response extinguishes. Okay? So we're going to skip over. This is another way of graphing the data. Okay? So let's just talk about the difference between the operant conditioning and classical conditioning. So in classical conditioning, if you remember, there's a stimulus that's followed, in this case the tone, is followed by the food, and the animal learns the tone-food association. The behavior of the dog, whether it salivates or not, has no effect on whether or not the food is presented or whether. So the key difference is that the animal operates on the environment. And here, in classical conditioning, the environment operates on the animal. So it's all about whether whether the environment is operating on the animal. In other words, whether you're learning about the environment, or in this case, you're really learning to manipulate the environment. This is why it's a sort of a much more powerful form of learning. And in both cases, the stimulus evokes a response. In one case, it's just an anticipatory or predictive response. In this case, it's a response that has a particular outcome. And the animal connects context, behavior, and outcome, where here it's just learning about a relationship. So this is why operant conditioning became sort of the focus of a lot of the research in learning and memory, because it was about the much more richer interactions between people and animals and their environment than just classical conditioning, which is learning about these associations. Operant conditioning is also the basis of training and education, including educating smart squirrels. And there are two ways. People often see animals in circuses or elsewhere, or even people's pets, do some sort of, or in the movies, do incredible things. And you ask, how do you train an animal to do that? Okay, it's easier. We saw before that we could train a rat to press a lever, but that seems a far gap between that and training a squirrel to water ski. And the ways in which these complex behaviors are trained in animals is through two processes. One called shaping, and shaping is successive approximation that you sort of build incrementally. So initially, you have some simple behavior, okay? And as the rate of response to that simple behavior increases, you keep moving to a more and more complex version. So shaping is basically saying we start with an easy problem, and once you get the easy problem done, which is sort of an approximate version, then you make the problem a little bit harder. So you start by reinforcing, for example, anytime the animal moves to the left, you reinforce it. And so eventually it learns in the face of the tone to move to the left. Okay? And then once it's learned to move to the left, you then make it harder. Okay, it's not just that you have to move to the left, but you have to move to the left by hopping. Okay? And it's only when it hops. So the idea is that you start with a general sort of simple behavior, and once that's learned, you make it more and more, you get more and more refined subsets of those behaviors that are actually correct. So shaping is how you get a sort of a single complex behavior. Chaining is how you chain them all together. So you start by reinforcing the animal for doing this one thing correct. And then once it's learned that one thing, you reinforce it when it does that one thing followed by something else. Okay? And so you build up a chain. And bit by bit, through shaping to get ever more complex components of a response, chaining to get ever more complex sequences, you can build up some of the sorts of amazing things that you can train animals to do. Okay? And of course, it's not just animals, but we can see this applied in all sorts of education, in training athletes and training soldiers and so forth. So shaping and chaining together require a lot of skill and patience. The animal has to be motivated. You have to have a proper training sequence. But both of these techniques we're talking about are sort of positive reinforcement. Okay, could you do the same thing by punishment? So you can train a squirrel to do this. You could train a horse like Mr. Ed to do various tricks. What about punishment? So a punisher is an outcome that decreases the frequency of behavior. And originally it was thought by Skinner that you couldn't use punishment because punishment would just generally suppress all behaviors. That's now not known to be true. A punishment is specific to whatever behavior came right beforehand, but it's much trickier, okay, to use punishment, in part because punishment does, although it may have an enhanced depression of what just came beforehand, it does also always create a sort of a general suppression, okay? And the punishment doesn't always wear off. You can often sort of habituate to a punishment after a while. So Skinner was wrong with it that you can't do this sort of operant conditioning with punishment, but it's very tricky. It's hard. The answer is it's not impossible. It's hard because animals may learn to avoid punishment. They may get sort of rage and anxiety, and they will have sort of general behavior. So there's a sort of therapists disagree about. The question is, well, what happens with training children? I mean, we're talking about training squirrels, but for many people who are parents, they're training children more often than they train squirrels, and they're often torn between training children using reward versus training punishment. And one of the things that Skinner was sort of arguing was that you should sort of only train children using using reward. In the real world, with real children, it's often a mix of the two, and in fact you can train behaviors with a mix of them. So the ways in which punishment, I said punishment is more difficult to use as a way to shape behavior. Interestingly enough, if you start with a weak punishment and then sort of escalate, as people do often, if you don't do this now, I'll speak to you sternly. Then if you do it again, I'll send you to your room. And then if you do it again, I will take away this. If you sort of keep escalating it, very often it's very ineffective. So a lot of studies in animals suggest that you actually need to start with the strongest punishment. That if you escalate up in punishments, you get a habituation. It needs to be immediate. Okay, so traditionally, in a more traditional father-mother roles from the 1950s, the threat to a child who's done something wrong is wait till your father gets home. You're really going to get a spanking. Okay, and so maybe 6 or 7 hours later, father comes home and the mother says, look what your son did, spank him, and then you spank him. Okay? That has very, very little effect on changing behavior. So it has to be really quite immediate. Now we're going to talk about schedules here. FR1 doesn't mean anything to you, right? Does anybody know what FR1 stands for?
Fixed ratio.
Right. So we're going to talk about what those fixed ratios are. So let me just skip this over. Let me skip over this. So let me just summarize. So animals, so interim summary of the behavioral processes in operant conditioning. You should know that animals adjust their behavior by tracking consequences of behaviors. The SR, actually we C, this should be outcome, not C. Okay, so there's a bit of an error in the slides here. The terminology is often, some people talk about O as outcome, some talk about C as consequence. Okay, these slides have a typo in that they mix them. So it should really be the outcome or the consequence. So it produces a pleasant outcome, increasing behavior. Remove a noxious outcome, increases behavioral response. Punishment, producing a noxious outcome, decreases behavior, and so on and so forth. So we'll go through some of these again. They're hard to get your mind around, but they're important for thinking about the ways in which behavior is being shaped. And animals are sensitive to the context in which learning occurs. So you have a discriminative stimulus, which tells when the context is relevant. So an example is, for a little child, peeing may be positively reinforced, but only in the context of sitting on the potty. Okay? So you want to train that for a small, so essentially potty training is training a child that in the context of having to go to the bathroom and sitting on the potty, that peeing is positively reinforced however they do it. Okay? The Skinner box is an idealized micro world with context, outcomes, and response. What's critical is an initial variability, which is then shaped by reinforcement or punishment to acquire a response. This response may asymptote at some level. You can only peck so fast. And extinction comes from removing the outcome, and the animal decreases. And it differs from classical conditioning, in which the animal is only passively learning about associations. And shaping and chaining are two ways that we can build up on the simplest of mechanisms of operant conditioning to get more complex behaviors. Okay. So we'll have sort of a little test. So Lois, I think Lois is the baby, I don't know, is sitting in bed and says, "This is great. I'll have to wake up and cry in the middle of the night more often." Okay? So what's the stimulus here? Okay. So who's being trained here? Okay. Well, only the parents? Right. So you can imagine that there isn't always one. So let's start by talking about Lois, okay? So what's her stimulus? Okay. She wakes up, okay, and crying, and the consequence is get warm and cuddly between mom and dad, okay? So she's being positively reinforced for her response, which is crying, okay? So this is positive reinforcement, right? Okay? So it's what kind of learning? So Lois is having positive reinforcement because crying is positive reinforced. Now what about the parents? What's the stimulus that they have? Okay, what's their response?
Bananas
Okay, and what's the consequence? Well, but also what else is the consequence? Okay, so what is this? What kind? How? Right, because there's something aversive, which is the baby crying, that's being removed. So the answer is, what kind of learning is going on here is it's both positive reinforcement and negative reinforcement that are being intermingled by two actors. And you can begin to see how interactions can be quite complex, where in a relationship, both people are conditioning each other. Okay? Here's a rat. He says, oh, not bad. The light comes on. I press the bar. They write me a check. How about you? Okay? So what's the stimulus? Who's being conditioned here? Okay? What's the stimulus? That's a check. So what kind of training is that? Right. Okay. So let's talk about sort of putting it all together, putting together the stimulus-response outcome association. So what determines the effectiveness of operant conditioning? Okay, two things are critical: the timing from behavior to consequence, and the relationship between the behavior and the consequence, the schedule. Okay. So I'm going to go through some of this. I'm not going to spend too much time here. I see that light's not, that clock is not working. Oh no, it is fine. So the first thing is that, remember I said that, saying Dad's going to come home and spank you in 6 hours? So the longer the delay, the slower the learning. Okay? So, all right. So in operant contingency, a schedule of a contingency is learned. So if S, then if stimulus, then response leads outcome. Let me skip through some of this. So there are many ways in which an animal can be trained. Let's just talk about positive reinforcement at the moment. So let's go over here. Let's skip over here. So there are fixed ratios, so different types of schedules, different ways of training. And these are important to understand, partly because different laboratory designs use different ones, but also they help us understand what's happening in a real-world situation, if we can think of it in terms of what we know about these different schedules of reinforcement in the lab and what they tell us about ways of training the real world. So fixed ratio means every X responses, you get one outcome. Okay? So fixed ratio of 1 means every time you do something, I give you a response. Every time you come and mow my lawn, I give you $10. Okay? So here, this is the response, the lever. This is the ice cream, which I guess is reward. So here we see fixed ratio of 1. Okay? That's fixed ratio of 1. Here, every other time I press the lever, I get an ice cream cone. That's fixed ratio of 2. Here, fixed ratio of 3, and so on and so forth. Okay? So it just really tells you how many responses you have to get a response. I'm going to skip over some of the more details here. Variable ratio means every so many R's produce a response, but it will change. So it says that there's a variable ratio that will change over time. So what's happening here is that there may be an average. So basically, a fixed and a ratio is, in the ratio case, it's a certain percent of the times it'll happen, but you don't know on any given trial what will happen. So here what you're seeing is that there's a low ratio, response, okay? So overall, there's a variable ratio of 6, which means that on average, over the experiment, for every 6 times, there were a total of 30 responses and 5 rewards. So it says on the average, you need to produce six responses to get 1 reward. Okay?
In all these cases, there's one stimulus?
In the simplest case, yeah, there's 1 stimulus here. So the idea here is that there's a ratio which says that 1 out of every 6 responses will be rewarded, but for any given trial, you don't know what it'll be. Okay, let me skip over this here. So those are ratios. So it's either fixed ratio or variable ratio, which says that in both cases, the more you do, the more you respond, the more you'll get rewarded. It just depends on whether it's a fixed ratio or a variable ratio, whether it's sort of percentage. Okay? Fixed interval says that it doesn't actually matter how many responses you give, the timing is what matters. So in the first case, it's the response. So after so many seconds, a response will produce a consequence. Okay? So this says that after a minute, after a minute, if I respond, I'll get reward. And then I have to wait another minute. And it doesn't matter what happens in between, okay? Fixed interval 1 minute, here fixed interval 2 minutes, you have to wait 2 minutes, and then you have to respond. You still have to make a response, but there has to be a delay before that response becomes applicable. So what's the effective behavior before the interval is up? Remember, in a fixed ratio or variable ratio, the more you respond, the more you're going to get rewarded. Okay? Here, it doesn't matter. Before the interval expires, it has no consequence. Okay, so you could add all sorts of, you could add all sorts of responses going on in the interval. Doesn't do you any good. So the idea here is that really what there is, one way to think about this, is that in a fixed interval, the context isn't just the light being on, it's the light being on and it having been a minute since the last time you got rewarded. So you have a sort of a complex discriminating stimulus. It's a combination of the light or whatever else is on, as well as the time delay. Okay. And I'm going to skip over some details. You can read more details about this in the book. I just want to give sort of a broader overview. A variable interval is after so many seconds, one response produces an outcome, but the y changes after each c. So the behavior before the interval expiring has no consequence. So let me explain what that means. It's a little complex. Okay? So what it says is, just like a variable ratio means there's certain percent of times, here the intervals vary, across time, and there may be a sort of an average interval, but you don't know exactly what it is. And for any particular interval, again, you get still no effect. Okay? And I'll give you some examples here. So a lot of the studies of these kinds of ratios have looked at the ways in which they reinforce learning in different ways, and the ways in which the kinds of responding that you get. So for example, you'll get, in these interval studies, you'll often get responding, slows down, which is what you'd expect. In the period where doesn't matter how often you respond, eventually the animals or people learn that it doesn't make any sense to respond until it's just about 1 minute. So you'll see a slowing of response and an increase right when the interval is over. So I'm going to skip over some of this here. What's key is that variable ratio, the more responses, the more reinforcers. You sort of have to play to win, whether it's in the variable interval, the more responses doesn't necessarily mean more reinforcers, but you just need to check in every now and then. Okay? So let me just briefly sort of summarize this, and then we'll go back, and sometimes it's easier to understand these concepts with some real-world examples. So the nearer behavior and consequences, the better the learning. That's sort of standard. The schedule is steady, strong responding, so a variable ratio. So one example is gambling. Okay, in gambling, okay, it's not the case that every time you put a quarter in the slot machine, you get back a reward. Okay, it's variable. It's you don't know how often it'll be. It's some sort of small ratio, but a certain percent of the times that you do the response of putting in a quarter, you get back a reward. Variable interval produces this produces very strong responding. You see the people at the slot machine, because the more in a ratio schedule, the more you respond, the more likely you are to win. So that's why you see these people at the slot machine hour after hour, putting in quarter, putting in quarter, putting in quarter. Okay? A variable interval is something where you'll get reward, but you don't really know how long it's going to be till the next point at which you'll be rewarded. Checking email is an example. Okay, lots of you check your email throughout the day. Okay, we'll consider getting emails. We'll assume all your emails are rewarding and positive. So the point is, it doesn't matter how often you check your email, you will still won't get a message from your girlfriend any sooner. Okay, and yet still people will keep going checking their email over and over and over again. Okay, so you have to keep checking it periodically, but the more you check your email doesn't make it any more likely or frequent that you're going to get that. Okay, fixed ratio gives you sort of steady, moderate responding. So for example, piecework. What piecework means is you get reward. Let's say every 10, in a piecework, you used to refer to people in factories. Every 10 shirts that you sew, you get paid $1. Okay, and so the idea is that you just keep sort of plugging away, and you're being paid, per item or per n items, and you keep sort of going. Fixed interval would be low responding because it's been a while since you've been reinforced, and then high responding just before the expiration. So it might be checking cookies. Okay, so you put the cookies in the oven, you know that they're not going to be ready right now, so you don't keep checking, but you know the cookies take about 10 minutes to cook, and so as you get to 8-9 minutes, you're sort of checking in to see how they're doing. So to be sort of low responding initially after you put the cookies in the oven, and then a lot of responding where responding is checking the oven just beforehand. Okay, so the idea here is the reason these schedules are important is because understanding the nature of the reinforcement, whether it's variable or fixed, whether it's interval or ratio, will allow you to understand the pattern of behaviors that will emerge. So here are some examples. We're talking about fixed ratio. Okay, so I'm going to give you 2 examples and then open it up for you guys. So fixed ratio is a child gets a gold star. Each day she picks up her toys. At the end of a week, 5 gold stars can be exchanged for a toy. Okay, so every 5, you're basically reinforced every 5 picking up of toys. If you have bad breath, okay, so that's here we get positive reinforcement, getting a toy. Chewing gum takes away bad breath. 1 stick of gum, okay, this is negative reinforcement. You're taking away something bad, which is bad breath. Okay, so 1 stick of gum will remove the bad breath. Okay, so what are some other examples that haven't been covered here of fixed ratio from the real world? What are situations where you get rewarded every n times for something you do it?
And if you take out the trash like twice a week, you get an allowance for it.
Okay, so it's another sort of parental training. How about anything else that happens in the world where you get fixed ratio?
Work, the amount you get paid per hour.
You get paid per hour. So for every hour of work, you get $10. Okay, that's another example. So that's a very common situation. Fixed interval. So putting a news magazine to bed. To bed is a sort of a term for finishing, for publishing it. So the work gets faster and faster as the deadline approaches, followed by a short post-reinforcement pause before the work begins in earnest. Okay, probably a better example for those of you in graduate school is putting in an NIH grant. It's like, March 16th, that's ages from now, our grant's not due for a while. Suddenly it's 2 weeks before the grant, a week before the grant, and as many of you know, in the last 24 hours before an NIH deadline, although you've had 4 months since the last NIH deadline, there's a massive increase in work of the equivalent of pressing levers is getting everything all together to put the grant in. Okay. Another is often sort of seniority-based raises. People get reinforced, but not all the time. It's not every great time. It may be only every 2 years or so. You're sort of evaluated, and then if you've done good work, then you get a raise. Okay. Any other examples of fixed interval where you pretty much you get reinforced at some particular time point that's independent of how total many you've responded in between?
Payment by salary rather than hours.
Okay. Okay. Now the question is, but does that produce that sort of scallop responding? Are you working extra hard?
Right.
So it's not quite, you're not necessarily working extra hard in the last day or two of a 2 week period. studying for an exam that's going to happen in 2 weeks. Okay, you could be studying regularly throughout the week. Okay, but invariably what winds up happening is you're studying a lot up right before the interval. So variable ratio. Telemarketers might make an average of 2 sales per 20 phone calls, but they never know which phone calls are going to lead to sales. And the more phone calls they make, the more they're going to get rewarded. So here's an example where there's some ratio of, I don't actually like the word variable. I think it's actually confusing because it makes it sound like, I think what it really is one is fixed and the other is probabilistic. Again, I don't like this terminology because it's not intuitive. I think a better terminology would be to call this sort of a probabilistic ratio rather than a deterministic ratio. That's probably the better way to think of it.
Would not be very freshmen trying to get into the bars in New Brunswick with fake IDs.
So freshmen trying to get into the bars in New Brunswick with fake IDs. So you just keep going. You just go to one bar after the other until eventually. Okay. Sure. Any other examples?
You take enough exams, you might pass one.
I see. It's sort of like if you put enough monkeys in front of a typewriter, eventually they'll write Shakespeare. What? So what's the lottery? Yeah. So what is that a variable ratio?
You know, with the scratch off, there's a
Right.
probability.
Right. Same thing with the slot machine. You know, every time you buy a scratch off, every time you put a quarter in. Okay. So let's spend about 45. Why don't we just take before we go into the brain stuff, because this will be a slightly shorter lecture overall, why don't we just take a break for about 5 or 10 minutes, and then we'll come back, and then we'll do the brain side. Okay, so we'll turn now to talking about the brain substrates of operant conditioning, talk about the dorsal striatum and stimulus response learning, the orbital frontal cortex, and a little bit about mechanisms of reinforcement signaling in the brain. So operant conditioning requires integrated activity of many brain areas, not surprising because we've talked about operant conditioning as being the ways in which stimuli, responses, and outcomes are all brought together. A short sort of summary of the bottom line is the dorsal striatum seems to play a role in linking the stimulus with the response. So that's the SR part, stimulus response. The orbital frontal cortex, and although it's not mentioned here, orbital frontal cortex and the ventral striatum play a role in linking responses with outcomes. Okay, the response outcome. Okay, so here we see stimulus response and response outcome. Okay, so here's a sort of a broad overview. The basal ganglia are a set of subcortical structures that link sensory and motor cortices, among other things. And within the basal ganglia, the dorsal striatum, okay, that's this part up here, okay, which includes the caudate nucleus and the putamen, seems to play a particularly important role in linking stimuli and responses. Okay, so the habit component of the operant conditioning. Okay. In rats, lesions to the dorsal striatum produce major deficits in operant conditioning. In particular, simple response SR relationships are learned correctly, such as press, lever, get food, but no learning takes place with the discriminative response. So the idea is you could learn to press a lever, but you can't learn only to press a lever in response to a light being on. So it suggests that the dorsal striatum is particularly involved in linking a discriminative stimulus with behavioral contingencies. Here's a broad overview, which is you have a stimulus. Okay, so we have to link together the stimulus, the response, and the consequence or the outcome. The stimulus comes in through the visual system. Here's the motor system, the basal ganglia, which can produce a response. The response leads to some consequence, the outcome. The outcome can affect taste, good taste, bad taste. It can affect hunger. This leads to a sort of the reinforcement system, which is then going to modify this. So we have this sort of this loop from the stimulus produces a response, which affects the external world and comes back and alters our reinforcement pathways. So one of the ways in which this is studied is by electrical stimulation directly to the reinforcement pathways, in this case in the ventral tegmental area in the brainstem. The VTA is a center for dopamine modulation of the basal ganglia. And so VTA stimulation is a very powerful reinforcement. Rats, if given a choice between pressing a button that gives them VTA stimulation versus eating food, will starve themselves to death so they can keep getting more of that stimulation. Okay? So this is sort of the idea here, is that if you have electrical brain stimulation, you can sort of directly activate the reinforcement system and have someone do a habit over and over and over again to the point where they're sort of out of their control. Some of these VTA neurons extend to the nucleus accumbens in the basal ganglia. Nucleus accumbens sends dopamine to motor areas. So dopamine, it's been argued, may be the physiological basis for wanting aspects of reinforcement. So the idea is that you're wanting something, this sort of this craving, okay, is controlled by dopamine, which is why it's very often believed to be involved in addictive behaviors. That the way in which dopamine modulates the degree to which you want something, okay, or your motivation, is what's disrupted in drug addiction. So I'm going to skip over this. So one of the most important results in understanding dopamine comes from studies of the role of dopamine in conditioning, from recordings that are made of the dopamine neurons in the VTA in a monkey's that's being conditioned to reward or to omission of reward. And so in this study by Schultz, the dopamine neurons in the monkey's midbrain respond strongly, but only after unexpected rewards. Okay, and so this is where we saw evidence of its role in reinforcement learning. If the reward is predicted, for example, by a light, okay, so here if a light occurs before food, dopamine neurons increase, but not after the food. Dopamine neurons decrease activity after an expected reward does not occur. So this is sort of an omission. So the idea is that these dopamines firing is going to encode, if there's an increase, there's an unexpected reward. If there's a decrease, there's an unexpected absence of reward. And it was suggested, therefore, that these dopamine neurons capture the notion of reward prediction, that they are coding the degree to which reward is predicted and how that prediction map relates to what actually occurs. So here's the study. This shows a monkey that is just being given an unexpected juice, and these dopamine neurons increase in firing. Here a light has been paired to predict the juice. So now there's no more dopamine firing to the juice, but there is dopamine firing to the light, which predicts the reward. If you, in an extinction trial, okay, so this is sort of what you might call a US alone trial, okay, the outcome is presented. This is a CS-US trial in a well-trained animal. And this is a CS alone trial in the beginning of an extinction paradigm. So the CS has been presented, there's no juice, and what you see here is there's a depression of the baseline firing rate. So suggesting that the dopamine is capturing not the reward itself, but the prediction error, the degree to which the reward is unexpected. Another aspect of the reinforcement pathways are the endogenous opioids, like endorphin, which are related to heroin, similar in turn to heroin or morphine, and they bind to the brain's natural opiates. And it's been suggested that these opiates provide information about liking. And one of the things that's come out of the studies of the neural substrates of operant conditioning is the idea that there may be that there may be things that we like, and that's sort of separate from the things that we want. And it sort of provides an interesting insight. We tend to think at a casual level that we want the things that we like, okay? But very often, it turns out these may well be very separate pathways, which is why we can often get ourselves in situations where we actually want something that we don't necessarily like, but we have this craving for it. We compulsively can't stop it. And suggests why many behaviors may ultimately be destructive, because the wanting sort of moves away from things that we will naturally like. Okay, and I remember seeing one quote where someone asked someone who was a cocaine addict, you know, what does cocaine feel like? And they said, how does cocaine make you feel? And they said, cocaine makes me feel like I want more cocaine. Okay, so you've got this feedback loop of wanting that sort of is out of the absence. And addicts may originally like, the first time they have heroin, they may just absolutely love it, and they just feel fabulous. But what ultimately happens is long-term addicts often no longer really sort of like the drug. They don't feel pleasure in it, but rather they feel a a pain from the absence of it. Okay? So, and that they're taking it, they had this sort of this craving to take it in part because it relieves this craving. Okay? So, which suggests a transition. So let's just take that as an example. If somebody if the first time that you use heroin, you really like it, then what kind of operant conditioning is that from the schedules of reinforcement? Okay. An addict for some time who is feeling cravings and withdrawal, which is only remediated by having heroin, then what kind of reinforcement's going on there now? Huh? Exactly. The idea is that initially you're doing it because the heroin makes you feel good. Okay, that's why you do it. Later on, you're reinforced for taking heroin because it stops you from feeling bad. So one of the prevailing theories about the changes that go on in an addict's brain is that the reinforcement has shifted internally from being a positive reinforcement to a negative reinforcement. Okay. So in the brain, the stimulus response, consequence, or outcome, I'm sorry for the confusion there, may be stored in cortical connections via the basal ganglia. The brain's reinforcement system includes the release of dopamine from the VTA to the basal ganglia, which captures sort of the wanting. And the drugs that interfere with dopamine system will disrupt instrumental conditioning. And there are a variety of hypotheses on the interaction of dopamine and reinforcement. And there's the anhedonia hypothesis that dopamine gives reinforcers their goodness. There's the idea that there's the incentive salience hypothesis, which is that dopamine modulates wanting rather than liking. That is how hard an organism is willing to work. And a reward prediction hypothesis that dopamine signals whether reward is unexpected. And these are all different theoretical descriptions that one can read about in more detail. It's not clear whether they're all just different parts of the same story or whether they capture different roles of dopamine. So still an area for a lot of open-ended questions about how it is that dopamine is affecting our learning. Okay? And how it's disrupted in disorders like addiction. Okay? Just skip over that. So a quick anatomy quiz. What is this? More specifically, okay. And what is this? Down here? Great, okay. What kind of situation are we seeing here from a behavioral perspective? This top one? Right. And this is? Okay. Okay. So in this case, it's an unexpected juice reward, reward predicted, and predicted reward admitted. So the same thing. Okay. So let's just talk a little bit about some of the clinical perspectives, a little bit more about drug addiction. This lecture is going to turn out to be shorter than I thought. So pathological addiction is a strong habit that's maintained despite harmful consequences. Okay, very often I tell people, oh, you're addicted to coffee or you're addicted to cigarettes. And the question is, a pathological addiction has to be a habit that's despite the harmful consequences. So people can claim, oh, it doesn't harm me at all. So it's why it's often a source of semantics or argument whether or not you want to claim someone's an addict or not. People very often claim they're not addicted. They can give it up any time. They just have chosen not to for the last 20 years. Okay? It often involves a high, a euphoria that may come from taking the drug, and also an avoiding the withdrawal. Okay? One of the most common consequences of caffeine withdrawal is headache, which is why a lot of headache medicines are just caffeine. Okay? So seeking pleasure involves positive reinforcement. That may be why people begin to take a drug. Avoiding pain involves negative reinforcement, which is why they may maintain it. So although liking a drug may help initiate the addiction, the incentive hypothesis suggests that the addiction is maintained by wanting a drug. So this is sort of like, sometimes you just feel like a craving for another potato chip. You don't necessarily think you like potato chips, but somehow you just can't stop taking it. And so the idea is that somehow this wanting has been divorced from the liking. And all addictive drugs cause the decrease of dopamine, cause the release of dopamine in the ventral tegmental area. So whether it's cocaine or amphetamines or so on and so forth, they're all ultimately coming through this dopamine system and increasing dopamine. Okay. For example, amphetamines increase dopamine release. So you have here a presynaptic dopaminergic neuron, and the amphetamines are increasing the amount of dopamine that's released. Cocaine interferes with dopamine reuptake. So okay. So what's another drug that interferes with the reuptake? So SSRIs. So analogy is that cocaine is to dopamine what Prozac is to serotonin. Okay. So let's talk about behavioral addiction. So behavioral addictions are an addiction to a behavior as opposed to an addiction to a particular substance. It can produce euphoria. Understanding drug addiction may help understand some of these behavioral addictions. Compulsive gambling, eating, sex, internet use. Okay, all of you checking your email compulsively, that's a behavioral addiction. You can even be addicted to exercise. There's certainly many of us, and I would include myself, who, if we don't exercise according to our usual schedule, become irritable and fire people or break up with people or something when we haven't exercised. People are addicted to work. Okay, people who just compulsively have to keep working. Okay, so all of these, and one of the things that in our lab that we've studied is the ways in which dopamine drugs given to Parkinson's patients can often kick people into these sort of compulsives. So Parkinson's patients who may often be very withdrawn and harm avoidant, when they go on dopamine agonist drugs that would increase dopamine, can often become compulsive gamblers, sex addicts, and so on and so forth. So another evidence that these behavioral addictions are linked up with the dopamine system. Okay, so what can we do about some of these addictions? Does understand, if we're so smart and we know all about instrumental conditioning and dopamine and addiction, how does that actually help? One approach is naltrexone, which is indirectly inhibits dopamine production. Mohammed, do you know anything you can add about the mechanism of naltrexone?
I remember that it blocks the release of dopamine.
So it inhibits, it blocks the release of dopamine. Sue?
Oh, I was thinking that it binds to the opioid receptors. Isn't that right?
Yeah, because
Yeah.
it's meant to
Because it-
displace heroin.
It's
You
been-
give it to overdose.
And it's actually now being used very controversially by a French pharmaceutical company who's using it for weight loss. So,
To somehow make the food less
clearly
pleasurable?
The food that triggers the opioid receptors, the naltrexone blocks the
Uh-huh.
receptors.
So it makes food less pleasurable.
Yeah, but the interplay
Why don't you send people to England and make them eat English food instead? That's just the same, they'll have the same effect.
But the interplay between, opioid receptors and dopamine receptors is very strong. Because you're talking about a very strong system at the level of ventral striatum. And they interact all the time. So if you block one of them, that will have definitely an effect.
Right. We're actually involved, our lab, with a study going on at UPenn, where I mentioned before that about 20% of Parkinson's patients who are put on dopamine agonists develop these behavioral addictions. And I believe what they're doing is they're studying what happens if you give them the dopamine agonist and you also give them naltrexone, which in some sense, if it's inhibiting dopamine production and dopamine agonists are trying to increase it, one question is this just going to undo the effects of the medication? But so the question is, can you give people naltrexone, not interfere with the Parkinsonian, the motoric advantages, but reduce the propensity for these addictive behaviors?
But also there are another class of drugs which is antipsychotics,
Uh-huh.
which is a D1, D2 antagonist. And one of the main side effects is Parkinson's. So that's another way to think about it as well.
Right. Is that those drugs are enhancing dopamine. I'm sorry, those drugs are reducing dopamine effects.
Yes.
Therefore, they can cause Parkinsonian-like symptoms. Okay. Cognitive behavioral therapies. So we've seen a lot of ways of altering reinforcement learning behaviorally that come through extinction. Okay, reinforcing alternative behaviors. So what's an example of a cognitive? Let's say someone's addicted to cigarettes. Okay, a nicotine addiction. How could you cure them? What would be an extinction? What would be a way of extinguishing an addiction to cigarettes?
Giving them something else when you crave it.
Well, yeah, so let's talk about what is in a cigarette addiction, what's an example of the SR outcome contingencies?
You get a craving.
Right, and so when do you get a craving? A lot of people, exactly. A lot of people, it becomes, when they're drinking, after sex, they need to have a cigarette, when they go to a bar, okay? So obviously one thing to do is don't have sex and don't go to bars. The other would be, an extinction would be to sort of go to a bar, with someone who's making sure that you don't smoke, and keep going to a bar over and over again until you no longer associate it, okay? Reinforcement of alternative behaviors. What's a standard reinforcement of alternative behavior for someone who's trying to quit smoking? Exactly. Okay. Exercise, exactly. Every time, good thing. Every time you feel that craving for a cigarette, go out and work out. Cheesecake. Okay. Okay. Delayed reinforcement. So, right. So one of the things that often is, you could say, well, when I feel this craving, I won't smoke immediately, but I'll wait a minute, and then I'll wait 5 minutes, and then 10 minutes. So you sort of almost get like that chaining of behaviors. You chain 1 minute delay is sort of reinforced, and then 2 minutes delay, and 10 minutes delay, and so on and so forth. Okay. All of these are sort of based on various instrumental conditioning paradigms. So let me just sort of briefly summarize the clinical perspectives. Addictive drugs may hijack the brain's reinforcement system, and this may be both psychological as well as a physiological addiction. Behavioral addictions may reflect some of the same brain processes, and dopamine. Treatments for addictions may include cognitive therapy, medication, behavioral therapy, okay, and can include many of the principles that come from instrumental conditioning. Okay, that was a shorter lecture than usual. Thank you.